Hello everyone and welcome to this new video about the Go programming language. And today we're going to look at maps, which are also known as hash maps or sometimes dictionaries. And well, what actually are maps? So if you come from another programming language, maybe for example Python or I don't know, whatever other programming language, you're probably used to the concept of a map, but maybe under a different name. For example, in Python they're called dictionaries, dict type. But in Golang, the actual name of this object is that of a map. So a map, in general terms, it is just a way. Map is just a way that to basically associate, we could say. So take a, for example, a string, and associate to this string a certain value of another data type. And this cannot only be a string. This can be in general any other data type that you can think of. So in general, this is data type 2. Okay, so you can just associate via, and this is done by a hash function. You can just associate data types with other data types, and you can access whatever we could say other data you assign to it. And so this is very, I could give you a use case for which this would be useful. For example, imagine that you wanted to check of, I don't know, the monthly income of, for example, imagine that you had a map that stores the monthly income of all of your employees. And imagine that maybe you want to check the monthly income of John, I don't know, like X, whatever surname you can think of. And then maybe you want something that returns to you, I don't know, some random number. Or for example, imagine that you have a table that shows the age of some people, and then you want to check the age of this person here, and it returns 25. And another person, for example, Mark Z, and it returns 18. Okay, something like that. Well, how can you do that with a map? Well, you can do all of this with a map. So first of all, let's see how we can declare a map. So we will use the var keyword as usual. Then we can call map name, and the type of this element will be a map. Then in the first square brackets here, we will basically indicate the type of the keys. So the things which we use to access data are called the keys, and the values are the elements that we are accessing. So let's suppose in the example before we wanted to create a table which shows the age of people. So the keys will be strings, because we want to say, okay, what is the age of Jack? Well, then it will return a number. And well, the number is an integer, because the age, of course, is a positive integer. So we will use int. And then we will set this equal to, if we want to initialize it and declare at the same time, we will see how we can do this first. We will basically use these curly braces after map string int repeated here. And then we will just start to write the key value pairs. So for example, Jack 25, John 19, Mark 20, I don't know, like Paul 40, and maybe that's it. Now let's try to and that's it maybe. So let's try to print ln map name of Paul. So you can see you can access the values given a key just by writing the key inside the curly braces. So let's try and run this. Go run, it was apps.go. It will give 40 because we have said that the age of Paul is 40. So we can also not directly declare and initialize a map. We can also initialize it later. So how can we do that? We can just use the make keyword, and then we can set inside map string int, and then we can just for example set Paul equal to 40, and then map name John equals to 25. So let's try and run it. As you can see, we still get 40. This time we did not initialize and declare at the same time. We just first declared and then initialized. And then also notice that as before, we can also use the colon equal operator to infer the type. So if we do this, as you can see, it will still work because we are type inferring. So the compiler knows that the type of map name has to be a map from string to int. And now, as another example, you can also you can also of course declare maps which are not string to, of course, string to integer. You can also have all sorts of maps that you can think of. For example, you can have a map integer to boolean, or like float 32 to boolean, and maybe you can have a map of course, this is not really realistic, but imagine that you wanted to have a map that will tell you, well, for example, the value 0.1 is falsy, then the value 0.2 is falsy again, then for example 0.5 is, I don't know, like false again, then 0.7 is true, then 0.9 is true, and 1.0 is true. So now let's try to write map 2 of 0.3, actually 0.2. Let's try and run it. As you can see, we get false, because in our map it says that 0.2 is false. But let's try and increment this, for example, to 0.7. As you can see, we get true. And again, here you can also declare and initialize separately. So you can just declare it. You can use again the make keyword. So you're gonna make map, the map say full32 to a boolean, and then you can just remove all that stuff, and then we can initialize a little 0.1. You can set it equal to false, and then 0.2 we can set it equal to true. And if we try to run this again, you'll notice that it works as before. I think I did something wrong. Oh yeah, that's because that is 0.7. And also notice that by default, stuff that we have not initialized gets initialized to false. So that's another interesting stuff that we've also seen in the last video. So for example, we get true. So with this said, I think we've said enough about maps, and in the next video we will start looking at pointers.